Hello everyone, and welcome to your linear algebra review on the determinants of 3x3 matrices. My name is Jason, and I work for the ASU Tutoring Centers. Now, in calculating the determinant of 3x3 matrices, it ends up becoming very similar to how you calculate 2x2 matrices. In fact, you have to use the AD minus BC method that you use for calculating 2x2 matrices in your calculation of 3x3 matrices. So, the first thing you do, I'm going to be showing you the method called a cofactor expansion. And I'll explain to you exactly what a cofactor is in a moment. Now I'm going to try to do this explanation without getting too in-depth on the theory and the detail behind it, and just try to give you a direct method for calculating the determinant. So the first thing you do as a tip, you want to choose a row or column with most amount of zeros. You want to choose a row or column that has a frick ton of zeros in it, okay, as many as possible. So which row or column would you choose here? Well, we see a 0 on the bottom left, so I'm going to end up choosing this row right there. Okay, that's the first thing you have to do, is choose a row or column if you want to calculate the determinant of a matrix. Now what you end up doing when you do this is you're going to go through every single element of that row or column that you chose. Okay, so we're trying to calculate here the determinant of B. So I start with my first element of my column, of my row that I chose, which is 0. And what I do once I start with my first element, I'm going to cover up the row and column that element is in. That element 0 is in the first row and the first column, so I'm going to cover those both up. And you look at what you're left with. I'm left with this 2x2 matrix. This matrix is called a minor. And it makes sense, right? Minor, you typically think of minor, you think like smaller, younger, like typically ideas of being smaller. And this is a smaller matrix within your bigger matrix, right? It's a 2x2 within your greater 3x3 matrix. It's called a minor. And what you do is you're going to actually have to calculate the determinant of that minor and multiply it by this 0 that you started with. So I'm going to take my 0, I'm going to multiply by this minor. And then you have one more thing you have to do before moving on, is you need to decide what sign you're working with. Is there going to be a plus or a minus sign in front of this whole expression? And how you decide that is starting in the top left corner, you have a plus sign. So if you were to be doing this cofactor expansion off of like the first row or first column, and you're first starting with this 1, and you're starting with 1 and then whatever else here, the sign in front of it would be a plus. Okay? So the top left region is always a positive sign in front of it, and then it alternates. It makes like a checkerboard. So that plus is there, and then the next one's a minus, and the next one's a plus, and then it alternates for the next row. So instead of plus, minus, plus, it's minus, plus, minus, and then it's plus, minus, plus again. Makes like a little checkerboard. So this just tells you what sign goes in front of those coefficients if you end up using them. So here we're using the 0. So we look at what sign would go in front of my 0. Well, that would be a plus sign. Maybe I'll write that in black ink because that's official. Plus sign goes in front of it. Okay. So remember, this matrix here is called the minor. And if we were to include the sign that we chose, not including the 0, but including the sign, that is what we would call a cofactor. So the cofactor is the minor, so the determinant of the matrix, the minor, with its cofactor, with the plus or minus sign, okay? That's what a cofactor is. The minor with whatever sign is plus or minus. That is your cofactor. That's why it's called cofactor expansion. So this is our first cofactor. There are 2 more cofactors that we're going to need to calculate, okay? Because remember, all of this was done with just the 0. But we chose an entire row at the beginning, right? We chose an entire row. So we finished off with the 0, and now we have to move on to the next thing, the 3. So we cover the column it's in, we cover the row it's in, and we write out everything that's left. So now we're working with the 3. We covered the column and the row, and we're left with 1, 3, 1, 1. And we have to decide what sign goes in front of it. Well, if you remember, maybe I should have left them. This was a plus. This was a minus. This was a plus. So the sign that goes in front of it is a minus sign. And then we have one more to go to. We have this -1 over here. So we're going to go ahead and cover that column. So again, we chose -1. And the minor that we had along with it is 1, 2, 1, 4. And then it's a plus sign, right? Looking at that little purple mark there, the plus sign out in front. So this is what the determinant ends up being. And what we have to go through now is we have these smaller determinants, these 2x2 determinants that we have to end up calculating. And that we can use the formula from the previous video that we talked about, which if you haven't seen, you should check out, where it's AD minus BC, right? AD minus BC. Before we do that though, the reason that we have this tip for choosing the row or column with the most amount of zeros is look at this first term here. It doesn't actually matter what this determinant ends up being because we're multiplying by 0 anyway. So whatever that determinant is doesn't matter. When you multiply by 0, the whole term becomes 0 anyways. That's why choosing the row or column with the most amount of zeros is so useful. It saves you work. You don't have to calculate that determinant anymore. So let's look at the next determinant over, right? We have a -3. And then to calculate this determinant, it's AD minus BC. And then here we have plus a -1. So that's going to be minus AD minus BC. So here we have 1 times 1 is 1, minus 3 times 1 is 3, 1 minus 3 is -2, -3 times -2 is 6. Over here we have 1 times 4 is 4, 2 times 1 is 2, 4 minus 2 is 2. And then we have that negative out front, correct? Sorry, I caught it. This is a -4, my apologies. This is a -4. 1 times -4 is -4, 2 times 1 is 2, -4 minus 2 is -6, making that negative out front here. We have 6 plus 6, which ends up giving us 12. So the determinant of our matrix B is in fact 12. Okay, so this is the method that is the typical one taught for calculating 3x3 matrices, and then even 4x4, 5x5, however big your matrix ends up getting, is through cofactor expansion. So you pick a row or column, then you go through each element of that row or column, like we did here, right? We went through first element, second element, third element. When you go through that particular element, you cover the row and column it's in, and you write out the minor that's associated with it. And then the last thing you have to do is you have to figure out the sign associated with it, whether it's plus or minus. And the top left corner is always a plus, and then it just alternates throughout the rest of the matrix. So you just do that for every single element in the row or column that you chose, and then you have to simplify and simplify and simplify until you get your final answer of 12. So there you go, determinants of 3x3 matrices. Thank you all for joining me. As I mentioned at the beginning of the video, I work for the ASU Tutoring Centers. If you want more information about the tutoring services that we have, including the services we offer on all 4 major ASU campuses and online, please check out tutoring.asu.edu. For more videos like this one that go over specific concepts from your course, or maybe to see what upcoming review sessions we have for the exams in your course, go ahead and check out this link down below. Thank you all again, and have a fantastic day.